Hi Navraj, how are you? I'm good, thank you. Yes, so my name is Chirag Dhoble. I'm here to solve the doubt you have in algebra. So can you please explain me the doubt in detail? Yes. Okay. Okay, so you have a doubt in slope-intercept form of linear algebra. Okay, you need to learn how to draw a graph of a line or represent the linear equation using slope-intercept form, right? Okay, great. Okay, so don't worry, I will sort all your doubts in today's session. So let me just know if you can see my screen. Yes, I hope you're able to see my screen. Okay, great. All right, so linear equations, slope intercept form. Before we start, let me ask some previous knowledge from you. Do you know what are linear equations? Okay, all right. Okay, great. That means you know the basics of linear equations. It's just that the slope intercept form is something you are having trouble with. Okay, great. All right. So let's break down the term itself, slope intercept. Okay. Do you know what is meaning of slope? Yes. It is also called as gradient, decline or you can say incline, right? Let's understand a slope in our day-to-day life. We have slopes to our roofs, slopes on roads, and slopes almost at many places, right? So why do we provide slopes? There may be different reasons, right? Sometimes it is necessary. We cannot break down some patch of the road, so we provide an incline on that. We provide slopes on our roofs so that the rainwater can pass out of the roof quickly, right? So slope is necessary. So how much slope, how to calculate that? Because all of these are constructions, right? So it is it is important for us to find the slope and construct the equations based on that. Okay, so when we write the algebraic expression, the linear equation in terms of slope and an intercept, it is called as a slope intercept form. So let's understand how we can do that. Okay, all right. So let's say I have an incline like this. And I want to know whether this incline or this incline is steeper. Which one has higher slope? So obviously by observation, I can say that the first case has higher slope than the second case. But how much high? Because we are talking about mathematical terms here, right? We cannot just say more or less. We have to say how much more or how much less. So we have to have a method to describe the slope of a line in mathematical form. Okay, and for that we are going to use the Cartesian coordinate system. I hope you know what is a Cartesian coordinate system. Okay, great. So let's say I have a Cartesian coordinate system like this. Let me draw it here for you quickly. This is my y-axis and this is my x-axis. Okay, assume that they are straight. Now let me draw a line here. Okay, and one more line here. So obviously we can see they have different slopes, but we have to calculate how much slope they are having. So one thing you need to understand is that for the same spot, let's say this is the spot, the vertical distance traveled by the first line, let me name the lines. This is the first line and this is the second line. The vertical distance traveled by the first line is this much till here, right? And the vertical distance traveled by the second line is still here. So I think you would be able to notice now for the same horizontal distance, which is on the x-axis, let's say this is 5 units. The vertical distance traveled by those two lines is different. Let's say this is 2 units and this is entirely, okay, this complete distance is 6. So if you travel more vertical distance for the given horizontal distance, the slope becomes steeper. So I will say the line 1 has more slope than line 2. So the formula which we can write based on the vertical and horizontal distance is that slope S, sometimes it's also called as M, is equal to how much vertical distance traveled for how much horizontal distance. Okay, so V upon H. So now if you put in the values for line 1 and 2 into the given formula, M1, slope of line slope of line 1 will become, the vertical distance is 6, the horizontal distance is 5, 6 upon 5. Okay, so this is a bigger term than M2, which will be equal to 2 upon 5. The vertical distance is 2, the horizontal distance is 5. So 6 upon 5 is obviously greater than 2 upon 5. That's how we can mathematically measure the slope of a line. So the general formula of the slope of the line becomes the rise. The vertical distance is called as rise. This is called as rise, and this is called as a run. The horizontal distance is called as run. So the formula becomes slope is equal to m is equal to rise upon run, and that is in terms of coordinates y2 minus y1. The y-intercept, the vertical one, this is the y-intercept, the vertical distance, upon the horizontal distance x2 upon x1. Okay, because we started from the origin point, that's why there was no y2 and x1 and y1 here. But if we start from any point on the graph, let's say here, and then we are drawing the line, then we will have 2 points, right? Y1 x1 y1 and y2 x2. That's why the formula is like this. Okay, understood? So slope is equal to rise upon run. Now that we have understood what is the slope of a line, let's go to the slope intercept form and how it looks like. Let's see how the slope intercept form looks like. Again, it is made up of two words, slope and the intercept. So the slope is m and the intercept is b. Okay, this is the equation of the slope intercept form. Y is equal to mx plus b. Again, you notice how it is different from the general equation of the linear equations. General form of the linear equations. The general form is ax plus by is equal to c, right? So this is a general form, but in terms of slope intercept, in terms of slope of that line and the intercept of the y-axis, okay, the intercept is of y-axis. B is the y-axis intercept, m is the slope. So this is a general form, but if we have to write it down in terms of the slope intercept form, we have this as the general form. Y is equal to mx plus b, where y is a y is the y-intercept, but it is not of the equation itself. Okay, the y-intercept is actually b, and m is the slope of the line. Okay, all right. So now let's see how we can write this form of the from the given line, from the given equation. If we have a linear equation given to us, how can we write it in terms of the slope intercept form? Okay, so let's say I have, let me just erase, let me just insert one more slide here. Okay, so let's say I have an equation in general form as 2x plus 2x plus 3y is equal to c, that is 10. Now, how can I write this in terms of the slope intercept form? Nothing difficult, just rearranging the terms. I want it as y is equal to mx plus c. So I will make sure my simplification or rearrangement looks like this. So I'll keep y on one side. I'll try to keep y on one side. So first I will move the 2x from there. So 3y is equal to 10 minus 2x, and then y is equal to 10 minus 2x upon 3. Okay. Now I have to break it down in terms of mx plus c. So if I do that, it will be 10 upon 3. I'll write it later because I want the x term first. Minus 2 upon 3 x plus 10 upon 3. So I have the equation in terms of the slope intercept. M is the slope, that is, this is the M minus 2 upon 3, and this is my y-intercept B. So it becomes y is equal to mx plus B. Understood? So it's just rearrangement. Okay. Now, if you want to know how we can draw a graph from that, let's see how we can draw the graph. Okay. Let's say I have this equation here. Y is equal to 3x plus 1. Now, one way I can do that is just put the value of x. For some value of x, I will get value of y. I'll put another value of x, I will get value of y. I will plot those 2 points and I will connect them. That will give me a line. There's one more way we can do that. We will find the y-intercept first. The y-intercept is given actually. Y-intercept is 1. Okay, the y-intercept is 1. So we'll plot the point 0, 1. Because it will be on the y-axis. It's a y-intercept. It will be on the y-axis. So 0, 1. We'll plot that point first. 0, 1 here. Okay. Then we'll find what is the slope. What is the slope? Slope here is given as 3. M is 3. If you can relate it with the general form, you can see M is equal to 3. So our slope is 3. The intercept is 1. So once we know the slope, we can move 3 units up and 1 unit. Why? Okay, why 3 units? Because it's 3, that means 3 upon 1. So the vertical change is of 3, horizontal change is 1. So from this point, 0, 1, I will move, just a sec. Yeah, from this point, 0, 1, I will move 1 unit to the right, that is the run, and 3 units vertical, that is the rise. Because my slope is vertical change upon horizontal change, rise upon run, as we saw earlier. So I will get my new point, that is 1, 4. Okay. So now I have 2 points of the line. I can just connect them, and that will give me the line with the given equation, y is equal to 3x plus c, or 3x plus 1, sorry. Understood? So this is the slope intercept form, and using the slope intercept form, you can even draw the graph of the equation itself. And if they give you the general form of the equation, you can rearrange it in the slope intercept form. And from that form, you'll be able to tell what is the slope of the line and what is the y-intercept. Okay, great. So do you have any questions? Understood? Wonderful. All right. So I will stop here. Thank you for your time.